The role of water in our life is indispensable. One of the major techniques used to draw water from underground water table is by using submersible pumps in boreholes. Many households use the submersible pumps, but if there is a problem in this drawing of water, the pump has to be taken from the greater depth from where it is kept and the entire working of the house is interrupted. This limitation demands a mechanism in which the clog is sensed at its very excesses and cleaned at the very first detection, not allowing the further clogging, because more is the intensity of clogging, more is the difficulties faced during the rectifications.
Coming to the existing solutions, there are two solutions which are based mainly on the design of the impellers. One is the open impeller and the other is the cutting impeller. These impellers are designed in such a way that they prevent clogging as they allow particles to easily pass through them. But these impellers can only be used in sewage pumps as pressure isn't a factor there. But in case of underground submersible pumps, pressure needs to be maintained for a constant water flow, and so solid impellers are used, which also increases the chance of clogging. When clogging occurs, the traditional method of removal involves a rope which is tied to the motor and the components, by which they are taken out, disassembled and cleaned. Once they are cleaned, they are sent underground. This is a labor intensive and an expensive one too. These limitations can be overcome by a solution as the clog is detected and removed at its very first existence and in the site itself.
To begin with, we had to first understand the problem statement completely. So to understand the problem statement completely, we had to first understand what a submersible pump is and what exactly it does. A submersible pump is a vertical centrifugal pump and it pumps out water deep inside the earth to the surface. There are 5 major parts in a submersible pump. An induction motor which runs or which powers the submersible pump, and the inlet through which the water enters, impellers or set of impellers, and a set of diffusers corresponding to the number of impellers, and the discharge tube through which the water reaches the surface. Coming to the working of the submersible pump, basically we know that water has its own pressure, the inbound pressure. So water is pushed inside the submersible pump rather than getting pulled. So water enters the inlet of the submersible pump. So the walls of the inlet have sieve-like structures which helps in filtering the water that enters the inlet. So water after reaching the inlet goes to the impeller. So if you look at the structure of a typical impeller, there are 2 main parts, the eye of the impeller which is located at the center and the blades. These blades are also known as backwardly curved blades. These are called so because if you look at the direction of the blades of the impeller, it is in the clockwise direction. But then the induction motor would rotate in the anti-clockwise direction. This is designed so as to develop a positive pressure head. So from the impeller, it goes to the next impeller through a stationary device known as diffuser. Diffuser diffuses the water that is radially thrown out by the impeller axially into the eye of the next impeller. This goes on happening for a set of impellers and diffusers until it reaches the non-slam check valve. From the non-slam check valve, it reaches the surface through the discharge tube.
So for the clogging part, inductive proximity sensor is used. Inductive proximity sensor senses the magnetic losses in an external magnetic field when a metallic conductor is placed in front of it. The clogging primarily happens inside the inlet. The sensor is placed in a switch-on configuration. There's an amplitude drop all the time. Sludge formation occurs in the metallic part of the inlet. There will be no amplitude drop in the oscillating device of the inductive proximity sensor. The analog signal is sent to the Arduino board, which converts the signal to digital signal and reads it. If there is a formation of clogging, the analog signal is sent to the solenoid valve, which opens the valve letting the water to flush.
For the flushing part, we use a solenoid valve. After the Arduino board sends signal to the solenoid valve, it opens and closes. The solenoid valve works on the principle of electromagnetic induction. Solenoid valve consists of a coil, plunger, sleeve, assembly. In normally closed valve, a plunger return spring holds the plunger against the orifice and prevents flow. Once the solenoid coil is energized, the resultant magnetic field raises the plunger, enabling flow. The opening and closing of the valve depends upon the direction of the current flow. Some of the water flowing from the impeller to the discharge tube is bypassed onto the inlet by flushing through a small pipe of diameter 0.3 inches. At the end of the pipe, we kept a flusher, so it provides flushing across the inlet to the maximum, such that it is enough for the clog to get removed.